This will be our last installment of our types of mole conversions. And we're going to put together what we've learned about the mole in this lesson. So here's what we know. We know that the mole is our bridge, and it's going to connect our particles. And at this point of the year, the only particle that we've talked about so far is the particle related to the element, which is the atom. And we know that the relationship between moles and particles is that for every mole, there are 6.022 times 10 to the 23rd atoms. And this number is known as Avogadro's number. Then the mole connects us to the mass in grams. And this is known as the molar mass. And our conversion factor here is the number of grams in a mole. And the way we determine the number of grams is from the periodic table. All right, so that's a review of our conversion factors. And so let's look at my problem. Okay. So here's my first. I want to know how many atoms of carbon are in 0.020 grams of carbon. Okay, so last couple of weeks when we've solved problems, I've told you that the mole is our base unit. And if the mole appears in the question somewhere, then we know we only need one conversion factor. When I look at this problem, the units I see are grams and atoms. And so this tells me I'm going to need to use both of our conversion factors from the last couple of weeks. So what we're going to put in the first box is our given. So the given has a number, it has a unit, and it has a substance. And then underneath that, we can choose to leave it blank or put our placeholder 1. And we're going to use units to set it up. So we need our grams of carbon to cancel. So that's going to go in the bottom here. And according to my chart here, the only place I can get to from grams is I can get to moles. And then in my next conversion, I need those moles of carbon to cancel. And then my question wants to know atoms, and that's going to go on the top here. All right, so then we're going to plug in numbers. So if I'm looking at the molar mass, the number in front of moles is going to be a 1. The number in front of grams is going to come from the periodic table. So if you need to pause the video to get out your periodic table, go ahead and do so. To kind of help you along, carbon is a number 6 on the atomic number. So if you look, its mass is 12.01. Then we're going to use our other conversion factor. So again, if I look at that conversion factor, I can see that the number in front of moles is a 1. And the number in front of atoms is going to be my Avogadro's number. So 6.022 times 10 to the 23rd. All right, and then we're going to solve our problem. Now, in this problem, not everything on the bottom is a 1, so we're going to have to multiply across the top, and we're going to need to multiply across the bottom. So if you need to pause the video to get out your calculator to follow along, then do so. So I'm going to multiply my given, which is 0.020 times Avogadro's number. Remember that when you're multiplying times 10, you should be using that EE function of your calculator. And we don't round to the very end. So here's the answer my calculator is displaying to me. Okay. Then I'm going to do the same thing on the bottom. So I'm going to multiply all the numbers on the bottom together. And then we're going to divide. All right, and then this would be the point where we would round. So remember that when we're looking at Avogadro's number, it's whatever's in front of the times 10 that's significant. So that has 4 sig figs. The molar mass has 4 sig figs. My given, however, only has 2 since leading zeros are never significant. So your answer should be 2 sig figs. And you should have 1.0 times 10 to the 21st. And units, my grams of carbon would have canceled. My moles of carbon would have canceled. So this would be atoms of carbon. All right, so there's my problem number 1. All right, and then let me move my page along so we can look at our problem number 2. So number 2, I want to know the mass in grams. Okay, so there's 1 unit of my 5 times 10 to the 9th atoms. So atoms is my second unit of neon. So again, when I look at this question, there's no mole unit in the problem. This tells me I'm going to need to have 2 conversion factors. Again, whatever goes in the first box is always going to be your given. So the given has a number, a unit, and a substance. And you can choose to leave that space underneath your given blank, or you can put a 1 placeholder there. Okay. We're going to use units to set up our problem. So we're going to need to go atom to the base unit of moles. And then we need the base unit to cancel. And we want the grams of neon as our final unit. All right, so if I look at the relationships I have at the top of my page, the number in front of moles should be a 1. The number in front of atoms should be Avogadro's number. If I look at the relationships for molar mass at the top of the page, the number in front of moles should be a 1. And the number in front of grams should come from the periodic table. So neon is atomic number 10 on the periodic table, whose molar mass is 20.18. All right, so again, everything on the bottom is not a 1. So we're going to need to multiply across the top. And I don't round into the very end of all my calculations. And then I multiply across the bottom. And then I would divide. So again, you would have looked at the mass, you would have looked at the sig figs in Avogadro's number, and the sig figs in our given. The fewest sig figs is 2, so my answer is 1.7 times 10 to the negative 13th. And then in terms of grams, my atoms of neon would have canceled, my moles of neon would cancel, and this would be grams of neon. All right, so this concludes our mole conversion lessons.